Here's example 3 on dividing polynomials, long division. Remember, the divisor always outside the division box and the dividend always inside the division box. And another thing we have to be careful with the dividend is we have to notice our exponents, make sure they are in descending order, and also that any exponents that are missing, we fill in with 0, like we did in the previous example. In this example, we don't have this problem. We have a power of 3 and then the power of 2, power of 1, and power of 0. So all the exponents are there. We don't need to fill anything in. Let's start dividing. I look at the first term in the divisor and compare it to the first term in the dividend. And what I do is I ask myself, 3x times what will give me 3x cubed? And the answer to that is x squared. And then I multiply x squared times the first term in the divisor, and you get 3x cubed, and that's what we wanted. We want these to always match. And then I take that same number, that same term, x squared, and I multiply it times the second term in the divisor, which is a positive 4. 4 times x squared, positive 4x squared. And now we subtract. When we subtract, we're saying minus all of this. So this minus outside the parentheses will change to a plus, this will change to a minus, and this will change to a minus. So now I have this first term always goes to 0. 3x cubed minus 3x cubed is 0x cubed. And negative 11x squared plus negative 4x squared, that gives us negative 15x squared. All the other terms, I bring them down. Minus 56x and minus 48. Now I compare the degree of this first term with the degree of the divisor, and I notice that I can continue dividing. Whenever this exponent turns out to be less than the exponent in the divisor, that's the signal to stop dividing. Okay? So let's continue to divide. 3x times what will give you negative 15x squared? Well, I know 3 times 5 will give me 15. I want negative 15, so times negative 5, I'll get negative 15. And if I have x and I want to have x squared, well, I'll have to multiply by an x. So if I multiply 3x times negative 5x, I'll get negative 15x squared. Let's see. Negative 5x times that first term, that'll give you negative 15x squared. And negative 5x times that second term, which is a 4, is negative 20x. Now we subtract, and remember, this minus outside the parentheses will change to a plus. We'll change all the signs inside the parentheses. And now I have that this is 0, and negative 56x plus 20x will give me negative 36x minus 48. Bring down the 48. Again, we compare the exponent of this subtraction in the first term with the exponent in the divisor. Since they're equal, I can continue dividing. Whenever this power is less than the power in the divisor, then that's when I stop dividing. So now I look at the first term, and the first one here, 3x times what will give me negative 36x? Well, I know if I multiply 3 times 12, I'll get 36. So if I multiply 3 times negative 12, I should get negative 36. And x, I don't need to multiply times an x because all I need is x. And I already have it. So let's multiply negative 12 times that first term, 3x. That will give you negative 36x. And then multiply negative 12 times that second term, which is a positive 4, which will give you negative 48. And now we subtract. When you subtract, that changes all the signs inside. Okay? So negative 36x plus 36x, 0x. Negative 48 plus 48, 0. this is your remainder. You have a remainder of 0. That means no remainder. So the answer to this problem here is equal to this divided by this is equal to the quotient that you got, which is x squared minus 5x minus 12, and that's it because there's no remainder. So there you have it. I'll see you in the next video where we're going to do synthetic division, which is a shortcut to long division when the divisor is a linear binomial. I'll see you then.